तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Hello and welcome you all again to the lecture on computer graphics. In the last few lectures, we have been discussing about scanline algorithms, where we started with the method of drawing a straight line from one point to another. Then of course, we have moved to the case of the circle drawing algorithm, and both the in both these cases, the criteria which was used has been the Bressenham's midpoint criteria. So, basically you evaluate the midpoint with respect to the line or the curve in the case of a circle, and find out whether you have to select one of the two pixels, and this method gives us a very fast integer based algorithms to select points in a discretized or digitized environment. Okay. And towards the end of the last class, we have just finished the steps, equations and the mathematics related to the midpoint circle algorithm, where we have found out the increments necessary based on the choice of the east and southeast pixels, and we will move over today to the corresponding pseudo code of the midpoint circle algorithm. So, but before that, to maintain continuity, let us again have a relook at those expressions of the equation of a circle and the corresponding increment based on the choice of the midpoint criteria and the iterative loop. And if you look back to the slide, just I have rolled back the slides a couple of slides back. We are basically calculating points for the second octant. We are calculating points for the second octant. We draw a circle procedure which takes care of all the other 7 octants as we draw the circle. And so, when we are choosing points on the second octant, the choice is between east and the southeast pixels, okay, between east and southeast pixels. The equation of f of x y is given as x squared plus y squared minus r squared is equal to 0. That is the expression implicit form, and the midpoint criteria says that if the function is positive, then the point is outside the circle. If the value of the function is negative, then the point is inside the circle. So, this is the midpoint criteria which we use to calculate to find out whether the choice is east or southeast. And remember, we also used a decision variable d old as a function of the midpoint at the next stage of iteration, and the based on the current point xp comma yp, the functional value at the next midpoint will be f of xp plus 1 as given here at the bottom of your screen. As you can see here, yp minus half for the y coordinates, incrementally half down and 1 along the x direction to the right, xp plus 1. So, that is the, if you break open the expression of f of m, you will get the expression given at the bottom of the screen, which we have also seen in the last class. Okay. So, what's the choice for choosing east or southeast? We know that if the decision variable d is equal to 0 or positive, we choose southeast, that is the next midpoint m nu. It basically means when we are choosing southeast, the midpoint is above the line or the curve, and that is why the curve passes through closer to the southeast point, and so increment to positive 1 along x direction minus y along minus 1 along y direction, which gives us d nu. So, let us look at the expression of d nu now. And also straight away, since we know how to substitute and get the value of d nu, we look at the first order difference when the choice is southeast, which is d nu minus d old. The expression of d nu is given here, function of xp plus 2 along for x coordinates and yp minus 1.5, that is 3 by 2 in the y coordinate, minus the d old, which you have seen in the previous slide just now. Okay. So, d new minus d old will be given by this expression. So, 2 into x p minus y p or 2 x p minus 2 y p plus 5 is the increment corresponding to a choice of the southeast, and let us say if the decision variable is negative and we have to choose east, the next point is m new, okay, which can be obtained by incrementing 1 along x direction, which gives the d nu, and let us find the delta d or the first order difference or the difference in d. If east is the choice, it is also same like the previous case, d nu minus d old, where d nu in this case will be function of x p plus 2 and y p minus half. Instead of 3 by 2 for the choice of southeast, since we are choosing east, it is y p minus half minus d old here, okay, and that difference is given by, you can calculate yourself, will come as 2 x p plus 3. So, that means if you are choosing east, you increment the decision variable by a value 2 x p plus 3, whereas if you choose southeast, you increment by 2 x p minus 2 y p plus 5. So, please note down these expressions, because we are going to use these expressions with an example very soon today. Okay. What should be the decision variable at the start of the iteration? D start will be the first midpoint, because the first point chosen is 0 comma r. So, the next choice, the next midpoint will be plus 1, x naught y naught is 1 is 0 and r, and so it will be x naught plus 1 y naught minus half, and so it is f 1 comma r minus half, because 0 comma r, x naught is equal to 0, y naught is equal to r. Substitute that, this is what you get of f. Break open the expression for f, you get it as 5 by 4 minus r, okay, 5 by 4 a fraction minus r. So, we get a fractional floating point to start with, okay, and this diagram shows you typically the scenario at the start when x p y p has been chosen as the point of iteration at any stage, and the curve is passing over the midpoint. So, choice will be east. If the curve passes below the midpoint, the choice would have been southeast, and if of course you have chosen east, you have to evaluate the next midpoint criteria at the m of east respectively, okay. And but looking at the d start, we eliminate the fraction by substituting a variable h is equal to d minus 1/4. So, h of start will be 1 minus r, which will be an integer value, because we assumed at the beginning that r is an integer. Since r is an integer, h of start also will be an integer, okay. But and the small little problem is the comparison, because if you are comparing a bipolar case d with positive or negative comparing with 0, if that is the case, you are basically if you substitute d equal to 0 in this expression of h, you will get h is equal to minus 1/4. So, you have to compare with a negative fractional number, but you do not worry about this, because the last line that was given in the last lecture is, since h is initialized to an integer and also incremented by integers, so we can always compare h with 0 instead of comparing with minus 1/4. So, that is the where we stopped in the last class, where we had known now the expressions for d start or h start. We also know the expressions of the first order difference for east, that is delta E or delta SE for the southeast case, and all of these are now integers. And comparison also with respect to 0, positive or negative, you look at h instead of d and take a decision whether you move over to east or southeast. So, that is the logic behind the midpoint criteria. Let us look at the code behind it. Of course, we are not following any syntax in particular language, but it could be a pseudo code. It should be a pseudo code. We can code that in Pascal or C depending upon the environment you have, or C++. And let us look at the midpoint circle algorithm. Do not worry about the term version 1 for the time being. We will come with a version 2 which is a much sophisticated one very soon. Okay, so, that is the initial condition, put x equal to 0, y is equal to r, that is the initial condition. The other next initialization is substitute h is equal to 1 minus r. If you have seen that these are the 3 statements required for initializing. Okay, x equals 0, y equals r, that is the starting point, and the h start is 1 minus r, and if first plot the point itself at 0 comma r, that is draw circle, we will draw not only the point at 0 comma r, but it will also draw it in the other 8 octants as well. Okay, draw circle takes care of the other octants, because we are only calculating the points in the second octant. So, all the 7 other octants will be taken care of by the draw circle command. It will not only plot the point at x comma y, but 7 other points as well. Okay. Now, repeating this while loop as long as y is greater than x, because when the condition when you reach y is equal to x or y is less than x, it means you have come out of the second octant and you have entered first octant. So, we start from the top 0 comma r and we keep moving towards east and southeast. Typically, you will start selecting east initially and then southeast in general, we will see with an example, and you stop at the end of the second octant and the condition where you suddenly have a condition when x is equal to y or x will be more than y. So, keep doing this as long as this x is less than y or y greater than x. Okay. So, come back to the code. While y is greater than x, you look at the value of the decision variable, in this case h instead of d, compare it with 0. If it is negative, select east, and if you have select east, you remember that the delta E or the increment for the in the case of east was 2x plus 3. Okay, it was 2x plus 3. So, increment h by 2x plus 3. So, you see h is starting from an integer which is 1 minus r, and it is also going to be incremented by an integer 2x plus 3. Okay, we know that. Okay, else the condition, that means h is, in the previous case h was negative. So, it is either equal to 0 or positive now, and in this case select southeast, and if we all know that when we are selecting southeast, the increment in the value of h will be 2 into x minus y or 2x minus 2y plus 5, and you in this case, since you are selecting southeast, you decrement by y by 1, and the if condition ends here based on the choice of based on the value of h, you have selected east or southeast, and then you increment x by 1. You increment x by 1 and draw the circle. Okay. And then you keep doing this. Okay. You keep doing this in the while loop. You remember, let us go back to the previous slide. You started with the while loop when y was more than x. Okay. Y was greater than x. And then of course, you had an if statement here. So, this end if and end while shows the condition when you will finish the function of if and when you will finish the function of while. Only remember that the draw circle commands draw all the 8 points together, not only the point in the second octant, but all the other 7 octants as well. So, all the 8 points in all the 8 octants are drawn by the draw circle command, and you start with an initial value of h, which is an integer based on the decision variable h. You increment h by delta E or delta SE, which are also integers. So, it will be an integer algorithm, and it will be able to draw the circle for you. So, let us take an example now with this case. We will take the first example today for drawing a circle, and let us try to draw a circle with the center at 0 0 and the radius of the circle, let us say it is r, and I am only showing the points in the second octant. So, I have shown the part of the graphic screen, the raster frame buffer or pixels on the screen, and we have already plotted the first point at 0 comma 10. The first point comes at 0 comma r, isn't it? That is the first point in the second octant, which is in the top. So, 0 comma 10 is already plotted as shown by the red circle. We will finish the initialization first. Correct. Initialization involves h, which is 1 by r. 1 minus r is, since r is equal to 10, you will have the initial value starting of h as minus 9, and the value of x is equal to 0 initially, y is equal to r, which is 10, and you remember the increments of delta E and delta SE typically requires a computation of 2 multiplied by the x coordinate or 2 multiplied by the y coordinate, and that changes with time in each iteration loop. So, we will start with 2x, since x is equal to 0. Since x equal to 0, 2x also will be equal to 0, and since y is equal to 10, 2y also will be hence equal to 20. Okay. You remember, the first point is plotted at 0 comma r, which is 0 comma 10, and the draw circle will also draw the other 7 points in all these other 7 octants. We are only, remember, seeing the second octant, part of the screen with the second octant on it. That is what you are viewing. Okay. Let us get into the first stage of the iteration. The first stage of iteration, so this is the table which will show stage by stage of iteration, the k being the index of the iteration, first, second, and so on. H is the decision variable which will be incremented, 2x will be taken from the previous stage, x will be given, 2x will be taken, and 2y. So, when you enter the first iteration, what happens is you look at the first actually the value of h and decide what is going to be our next point. Since h is negative, you remember the condition, when h is negative, what happens? You select the east. Okay. So, automatically after 0, 10, the next point which will be selected is 1, 10, immediately to the right, the east pixel 1, 10. So, you will see in the first iteration the value which will be written at the bottom of your screen in the last row will be 1, 10, and 2x, 2y actually will be holding values from the previous iteration. Okay, or let us see. Let us see the values of the first iteration. As we get in and select the point which is 1, 10 as selected here, that is the point which will be selected and drawn after the computation, but the value of h will be incremented by minus n plus 2x plus 3. Remember, that is the increment 2x plus 3. What is 2x? 0. So, it will be incremented by a value 3. So, minus 9 plus 3, the h will hold a value 6. This h value of minus 6 will help you to select the next point, not the 1, 10. The 1, 10 point, which is the second point, has been selected by the value h, which is 9, minus 9. Minus 9 help you to select the first point, which is 1, 10 as given in the bottom of your screen and also marked on the red in the rastered screen, okay, in the grid, within the grid here, okay, and the h minus 6 actually will be used in the next iteration to choose the next point. What are 2x and 2y? Yes, the 2x and 2y values from the current iteration have been selected based on the previous point 0, 10 at 0 and 20 as already given here. In fact, 2x and 2y are computed within the loop, they are not part of the initial values, mind you, although it is given here. Actually, the initial value stops with selecting of h, x and y only. So, h is equal to minus 9, x equal to 0, y equal to 10. First three statements are the initial values. 2x and 2y, 0 and 20 are actually computed within the first stage of iteration. Within the first stage of iteration, they pick up the older values 0 and 10, and 2x and 2y are used to compute the new value of h. So, new value of h become minus 6. I hope you have followed the calculation. How? Again I repeat, h was actually minus 9, and since you have selected east, which is with coordinates 1, 10, the increment will be in delta east. So, h will be incremented by delta e, which is 2x plus 3. Since 2x plus 3, the increment will be plus 3. So, minus 9 plus 3 will give you minus 6. I hope you have written the expressions already in terms of what are where delta e and delta east and delta southeast. So, h minus 6 is also negative. If h is equal to minus 6, which is negative, again the next point selected will be the east pixel. Okay. So, you will select basically 2, 10. You will select 2, 10 as given by the second column of the table, the value at the last row 2, 10, it is also plotted on the screen, and then after that let us see the values which will be updated. Since x is 2 and y is 10, 2x and 2y are easy to calculate. Let us see how do you get h as minus 1. What was h initially? Minus 6. And since we have selected east, the increment again will be 2x plus 3, okay, where the value now of 2x is 2. This is the value which will be used to compute the new h. 2x plus 3 will be 2 plus 3, which is equal to 5. So, minus 6 plus 5 will give you minus 1. I repeat again, 2x plus 3, 2x is 2 plus 3 is 5. So, minus 6 plus 5 will give you minus 1. So, that is the new value of h which will take place at the end of the second iteration, and the coordinates which will be selected is 2, 10. So, as you enter the third iteration, you use the second updated value of at the second stage of iteration for h, which is minus 1. It is still negative. So, you will be selecting the southeast, I am sorry, the east pixel again, because it is negative. So, the next pixel selected again will be 3, 10, okay, as you can see here. This is because the h was minus 1 at the end of the second stage of iteration. Okay. So, let us enter the third stage of iteration. 3, 10 has been selected. It has been also marked here, and based on the values of 2x and 2y, what you typically have is 4 and 20. Okay. 2x and 2y, because 1, 10 gave you 2 and 20, 2, 10 from the previous iteration. Before updating, you actually got 4 and 20. Okay. This is the delta east will be now computed, or delta east southeast will be computed based on these values. You have to just follow the algorithm steps which have been given to you earlier and check the values with this table. Now, let us see how h has been updated. Remember, at the third stage of iteration 3, 10, that means you have actually selected east, and since you have selected east, you update the value of h, which was minus 1, by delta east. What is delta east now? 2x plus 3, which is 4 plus 3, 4 plus 3 is 7. So, 7 minus 1 will give you 6. I hope you have followed, as you have got 2 plus 3 which is 5. So, minus 6 plus 5 give you minus 1. Here 4 plus 3 is 7. 7 minus 1 is given you 6. So, that at the end of the third iteration you have selected 3 comma 10. The new updated value of h is equal to 6. That is positive. That is the first change which will occur. Since h is equal to 6 and it is positive, when h is positive or 0, you basically select, what do you select? Southeast, correct? So, you select the southeast pixel in the fourth iteration. Let us do that now. Let us enter the fourth iteration, and the x comma y value after 3 comma 10 becomes 4 comma 9. You see the new pixel here, southeast pixel selected, coordinates given at the fourth column of the table, bottom row 4 comma 9. Okay. So, what are 2x and 2y? In fact, you actually update h and then select the pixel, that is okay. So, 2x and 2y from 3 and 10 in the previous iteration is basically 6 and 20. And how do you get minus 3 as the new value of h? Well, h was 6, and since you have selected southeast, pixel from after the third iteration at the fourth iteration, your delta southeast will be the increment for h. What is delta southeast? You remember the delta southeast has an expression 2 multiplied by x minus y plus 5. For delta east it was 2x plus 3, which we have been doing in the first iteration. Okay, in the fourth, after the fourth iteration, basically at the fourth iteration, and since you have selected the southeast pixel, you have to increment the decision variable h by delta southeast, which is 2x minus 2y plus 5, or 2 into x minus y plus 5. So, let us look at the table. What are basically what are the values of 2x and 2y? If you carefully see, 6 minus 20 is basically 14, 6 minus 20 is minus 14, minus 14 plus 5 will give you minus 9, minus 9 plus 6 is minus 3. Again I repeat, how do you get minus 3? It is basically blindly, you can close your eyes and say it is 6 plus 6 minus 20 plus 5, okay? 6 plus 6 minus 20 plus 5. So, 6 plus 6 is 12 plus 5 is 17. So, 17 minus 20 will give you minus 3. I hope you are able to follow the calculations. Otherwise, work it out yourself with the formulas, follow the algorithm step by step, which I am also doing that quite slowly now, and you must follow. Rather than looking at the table, you should work it out yourself and check if these values of h, what you are getting is exactly what I am getting in this table. If not, please do and recompute it back, okay, and see. I hope we are all updated ourselves up to the fourth stage of iteration, and at the fourth stage of iteration, the value selected is 4 comma 9 for the current pixel, and then we look at h as we entered the fifth stage of iteration. Remember, we keep on doing that as long as the value of x is less than 5, otherwise there is no problem. We are in the second octant still, okay. As we entered the fifth iteration now, the value of h is minus 3, which is again negative. So, you have to select the east pixel. So, let us enter fifth iteration and finish the choice of the east pixel. After the pixel 4 comma 9, the next pixel is 5 comma 9 as given in the bottom row of the fifth column, and is also marked in the screen here as 5 comma 9, as you can see very clearly here. And that is what is done, and the 2x and 2y are incremented from, since x is 4 and 9 in the previous iteration, it is 8 and 18, and let us see how do you get the new value of as 8 of h. How h is updated? Since you have selected east, the increment is again 2x plus 3. Since the increment is 2x plus 3, 2x is 8, 8 plus 3 minus 3. I repeat again, delta E is 2x plus 3, 2x is 8 plus 3 minus 3, you can write those equation yourself, 2x plus 3 minus 3 is again giving you 8, okay. So, that is how you get the value of 8, and in the fifth iteration at the end we have chosen 5 comma 9. As we enter sixth iteration, still we are in the second octant because x is less than y. What is the value of H now, it is 8, it is a positive number. So, you have to select southeast. So, select the southeast pixel, the southeast pixel is 6, 8. Now, I hope you are through with the calculations, you are getting used to how this iteration stage is progressing now basically, and these highlighted colors, all colors are in blue in this table below. The colors which have been put in a brownish yellow brownish color or orange color, basically orange brownish color, are the values of 2x and 2y which are used in the computation for getting the new value of h. That is what, that is why they are, if they are not used, they are kept in blue. Okay. Now, fifth to sixth iteration, based on the value of h equal to 8, we have chosen southeast, which is 6, 8 here. 6, 8 is also marked on the screen. We have to only see what is the new value of h. H was 5. Sorry, excuse me, h was 8 in the fifth iteration, and since we are choosing southeast, so we have to increment the value of h by 2x minus 2y plus 5. So, it will be 8 plus 10 minus 18 plus 5. Again I repeat, 8 plus 10 minus 18 plus 5. You do the calculation again, you will find that it will be equal to 5, because 8 plus 10 is 18 and it cancels with the minus 18 term here, you are left with 5. So, the new value of h is 5 at the end of the sixth iteration, where we have selected 6, 8 as our point in the current iteration, southeast point. Okay. So, now what is the value of h at the end of the fifth iteration? It is 5, it is a positive number. So, again you have to select southeast. That means from 6, 8 you basically select 7, 7. Okay. From 6, 8 you select 7, 7 is your southeast, which has been marked here. Do not worry about the non-reds plot of this point for the time being, assuming that you have drawn 7, 7 is your next comma x, y, you update your new value of h as basically as 5 plus 12 minus 16 plus 5. I again repeat 2x 2y, because increment is delta southeast. So, h plus 2x, which is 12, minus 2x, which is 16 plus 5. So, 5 plus 12, 17 minus 16 is 1 plus 5 will be equal to 6. So, that is the current value of h at the end of the seventh iteration. But at the seventh iteration, we see now that x is equal to y, and when you have selected a point where x is equal to y, you have basically reached the end of the point in the second octant of your curve, and you do not have any more points in the second octant. So, with respect to all these points which you obtained starting from 0, 10, 1, 10, 2, 10 here, then 3, 10, all these for east, 4, 9 southeast, 5, 9 east, 6, 8 southeast, 7, 7 southeast. And I am showing this point because the 7, 7, which is the last red point drawn in this sequence in your raster image, is the last point in the second octant. The draw circle will draw all the other octants. This purple color point is actually drawn from the 7, 7, because the draw circle will generate all the other 7 points, and the other point you see at the right bottom of your screen, which is basically 6, 8, is nothing but the point generated in the first octant from 7, 7. So, just to show that that point is in the first octant and is automatically drawn from 7, 7, I have put this point. So, let us see that again. As you enter the seventh iteration, the values are selected, 7, 7, h is updated, and the points are drawn in the second octant as well as in the first. Since we are only drawing the second octant and a part of the first octant only, this is the one. And actually, let us look at what the circle should look like. This is what the circle should look like. Okay. Do not worry, the circle is getting out of the screen, but these are the spread of points of the circle of radius 10 at this origin, and you can see that the effect of aliasing on Jaggis in the case of a circle, as you had seen in the case of a line, how it can be so different from the way we are used to seeing circles. Okay. So, this is the spread of the circles, approximately of course drawn, I must admit here, but just to show the effect of Jaggis, this is the circle which is passing through the second octant and getting into the first octant only. Okay. And that completes the example of the stage of iterations to get the points in the second octant from the radius of the circle. So, given the radius, you are basically assuming that the origin is the center, and you get the points in the second octant, all the 7 other octants are drawn automatically. Okay. So, let us now look at if this was the case, is this a good midpoint line algorithm? Because I did say this is a version 1 algorithm. It works fine. I mean, you get the points which are the closest to the circle, as we have seen from the diagram just now. The points are the closest to the circle, the pixels are closest to the circumference of the circle, but is this okay? Well, I see, well, I will say no. Why this is not ideal? Let us look at the slide. What are the problems with this? Can you identify the problems? Well, the first problem, compared to the line drawing algorithm, in the case of the circle, it is because of the equation being nonlinear, is each of this iteration is requiring at least one multiplication and 3 additions per pixel, each of this iteration. Okay, compare the increment of the east and northeast pixel in the case of a line and the increment in the case of an east and southeast in the case of a circle. Delta E is 2x plus 3 and delta southeast is 2 into x minus y plus 3. So, at least one multiplication and 3 additions or subtraction operations is what you need to do per pixel. That will be very costly. Remember the midpoint line algorithm, we were just incrementing with integers, and that is what was making it fast. Within a loop, forget any operations like floating pointer around, we would like to avoid operations like multiplication and more than one addition if possible. So, the cost of the complexity rises due to the overhead associated with each iteration loop, which requires at least one or sometimes 2 multiplications and 2 or 3 additions per pixel, and that has been the main problem for the version 1 of the midpoint circle algorithm. It is correct, it is giving you the correct points, but the complexity is a little bit higher because of the overhead in terms of the computation required at each loop. Okay. So, that is the main problem, requires at least one multiplication, 3 addition per pixel, and I just told you the reason why this is so, because the delta D east and the delta D southeast are linear functions of x and y coordinates and not constants as in the case of a line. In the case of a line, the delta D east and delta D northeast in the first octant were basically constants, but in this case the delta D east and delta D southeast are linear functions of x and y coordinates, and that is what is giving you the multiplications and more than one addition per pixel. So, how to get rid of this? What is the solution now? Well, there is, and that is what we are heading towards, what we will call as the version 2 of the midpoint circle drawing algorithm, Bressenham's midpoint circle drawing algorithm, and all we have to do now is to calculate the differences which occur in delta D east and southeast from one point to the other, from one midpoint to the next midpoint. If we check the differences of the increments delta D and delta D southeast, which I will from now I will introduce a term, the first order differences in east and southeast. First order difference, delta D and delta D east and southeast are the first order differences which are functions of x y coordinates and not constants. Let us see what is the difference in the first order differences, and we will say these differences are delta D square for east and southeast, which we will call as the second order differences. So, instead of looking at the first order differences which we have done till now, we know the expressions of the first order differences. We have solved an example problem today to find out these points. What we will look for now is the second order differences. And let us see by chance if the second order differences are constants and not linear functions of x y coordinates, we should be easily able to derive an integer algorithm right now. So, let us look. We will say that under the choice, if we choose east, I introduce terms here, if we choose east, then we calculate the second order difference under the condition that we may choose one east after east or southeast after east. That may be a possibility, second order difference based on this. And same if we choose southeast, we can then calculate the second order difference that after choosing a southeast, we might choose again east or southeast. So, in fact, there are 4 possibilities of the second order differences. The first order difference is only 2 cases. You either choose east or southeast, that is over in the second octant as the curve proceeds down. In the second order differences, there are 4 possibilities. Under the condition you have chosen east, you can again choose an east in the second iteration. First, if you choose east, it can be followed by an east. Then east could be followed by a southeast. Okay? So, the first 2. What about the other 2? Well, you can choose southeast first and then choose east, okay, successively. We are looking at 2 successive operations, east and southeast, southeast and east, southeast and southeast. Okay. So, two successive midpoints is what we are looking, and we are looking in the differences in the first order differences of two successive midpoints, because the value of the first order difference at two successive midpoints will not be same now, because they are functions of xy coordinates. So, look into the second order differences, which is the difference of the first order differences. That is the second derivative function by mathematics as well. Difference in the first order differences is the second order difference. So, that is what we are looking in the discretized world or digitized space, and we will try to find out if this second order difference is could be calculated, whether these are integer constants. So, there are four possibilities of second order differences: east east, okay, east southeast, southeast east, and southeast southeast. We will calculate these in the next slide. Okay. So, I hope you will be able to follow this. So, what is the first choice? If we choose east, we are basically going from a point at current iteration xp yp to xp plus 1 and yp, that we all know. So, we will say the first order difference, which is old, is 2x plus p plus 3. This function we also know that the decision variable, this d means the h which we are talking. Okay. So, I replaced h by d, it does not matter, you can put the delta h here also, absolutely no problem, because it is a question of the start. But let us take the old variable d itself. 2xp plus 3 is the increment for if you choose east, and that I will put as old. What is the new? This new delta is first order difference under east is after choosing xp plus 1, if we also choose the next east point, the point will be the we are going from xp plus 1 comma yp to xp plus 2 comma yp, and hence the delta d east new value, first order difference new value will be 2 into xp plus 2, and that gives you 2xp plus 5, okay, because you typically get, if you get 2xp plus 3 from xp comma yp, then from xp plus 1 you should be able to derive this, that this is the new value. This xp plus 1 yp gives you the first order difference for the second iteration on new value, and the old value is dx plus p. Now, you can see that there is already a difference between the first order differences between the first midpoint and the next successive, immediately the next successive midpoint. And this gives us that the second order difference under the condition that we have chosen east and east again is basically 2xp plus 5 minus 2xp plus 3, or delta d east new minus delta d e old is equal to 2, because 2xp cancels out on both sides and 5 minus 3 will be 2. So, we have calculated the first second order difference, and if you have followed this, you should be able to follow the next other 3 stages of this other 3 different types of second order differences. I hope you have followed what is the second order difference in the first case when we have chosen 2 successive east points, one east and the second one east as well. Okay. Let us look into the second case where delta d southeast is old, which is 2xp minus 2yp plus 5. This expression is also known to us. That means we have chosen southeast in the first iteration, and again if we choose southeast, the new value of the first order differences will be based on this value xp plus 1 yp, that is the next coordinate. Okay. Southeast will be xp plus 1 and also will be yp xp plus 1, yes, sorry, that is the one, and the southeast new will be 2xp plus 1 minus 2yp plus 5. Okay. So, that is going to be the southeast new. Okay. So, this is under the condition that you are choosing east and then southeast will be, you have to subtract the second order difference for southeast under the condition that you have chosen east earlier. This is very interesting, because you must follow what is being done here. I am saying that in the previous case of second order difference between east and east in the first choice, again east, the second order difference will be the difference of the first order differences for E new and E old, which is equal to 2, but in this case again you have chosen east, all right, but the second one you could be choosing southeast, then it is the difference between these two expressions, and it will be equal to 2. Okay. So, that is very simple and straightforward. Let us look at the choice if we go southeast. I hope you have understood the previous case where the choice was purely based on east. Okay. Now, if you have chosen southeast, the point goes from xp yp to xp plus 1 yp minus 1, okay, southeast point, and the first order difference between old and new will be the expressions as given earlier. It is the same thing now, okay, and hence the delta second order difference delta D square under the choice of southeast, but looking at east again after south is equal to 2. And similarly, you can look at southeast old and southeast new. The values will be different now, yp minus 1, xp plus 1. You just substitute this second coordinate here, xp plus 1, yp minus 1 in the expression of the first order differences of old and new. Old based on xp yp, new based on xp plus 1, yp minus 1, which is the southeast pixel. So those are the expressions for southeast old and new. For the first order differences, take the difference is what you will get as your second order differences, which is equal to 4. If you subtract southeast old from southeast new, you have a 2 from this term coming out, another 2 from this term coming out. So it is 2 plus 2 minus 1 will give you a positive number. 2 plus 2 will give you 4. Okay. So I hope you will be able to calculate these and understood this. I will probably revise it once again. Let us go back to the previous case of east. When you have chosen east, these were the cases, because the point is moving from xp yp to xp plus 1 and yp. So use this expression to compute the delta D old and delta D new. Take the differences, will give you the first order difference under east and east. Okay. The subscripts indicate that you have actually chosen east and looking at east again. In this case, the second time I have chosen east, but I am looking at southeast. If I have chosen southeast after east, then I have to increment the southeast variable by 2, because the expressions are these as given by the 2 coordinates. So these were the first 2 cases, and in the second case, when we are choosing southeast, the differences come out in this form as 2 and 4. So the interesting point in this, if you have followed the calculations, please try to do it yourself, which will be interesting for you, is the following, that the second order difference are all integer coordinates, integer values. Excuse me, they are all integer values, and those integer values were like the case when we were doing scanline algorithm for a straight linear case. We also had integer values. Second order differences are integer. It helps to come out with a new version of the algorithm based on second order differences. Okay, and let us look at that algorithm now. Before that, we will just rewind the method. So at each step, we not only increment the value of h, but we also increment now the first order differences east and southeast. In the version 1, we are only incrementing h using the first order differences. Now within each loop, we not only increment h, but we also increment the first order differences of east and southeast. And how do you increment these? Because h is incremented by the first order differences delta DE and delta D southeast. These are again incremented by the second order differences. Correct? What are, since you had an h start, we need to have a delta DE start and delta D east southeast start as well. That means the first order increments, first order differences at the start for east and southeast at the starting. Okay, just substitute the value of 0 and r in each of these 2 cases, because we know the expression. We get the first value as 3 and another is 5 minus 2r. So these are the starting values. 5 minus 2r and 3 is what you get as the starting value for delta D. We know the starting value of h, we now know the starting value of the first order differences, and now we can look at a midpoint circle algorithm version 2. What does it say? The initialization part, unlike 3 steps for the version 1, has 5 steps, okay, where we initialize x, 0 and r. Okay, I use the word radius instead of r, but you can use capital R, there is absolutely no problem. You have interchange r and radius, you can assume this to be capital R, x is equal to 0, y is equal to r, h is equal to 1 minus r, first order difference is 3, okay, first order differences for southeast is minus 2r plus 5 or 5 minus 2r. So the initialization consists of 5 statements here. Draw a circle as like the previous case. Now let us look at the while loop, and the first if condition, when we have selected east, you first increment h based on the first order difference delta E in each direction. You do that, that is the one which you are doing in version 1, but in version 2 what you also do is, based on this, you increment the first order differences delta E and delta southeast by the second order differences 2 and 2 as have been evaluated earlier. This is under the condition that we had selected east. I hope you have noted down the expressions earlier and you are able to follow the algorithm. Okay. Let us look at the other if condition. When we are selecting southeast, yes, we do increment h by the first order differences of the southeast direction, that is delta DSE, and the first order differences of east and southeast are incremented by their second order differences respectively 2 and 4. Remember, we got 3 integers, 4 values of the second order differences. The first 2 cases were 2 and 2, the second were 2 and 4. I hope you have understood the derivation of that and you noted down these values. That has been what has been done. In the previous case, when we select east, the increment is by 2 each in delta D and delta southeast, and the second case it is basically 2 and 4. If you look into the slide, that is what you will happen. Select southeast, you increment by the second order differences 2 and 4. You decrement of course y by 1 always when you select southeast, and come out of the if loop, not the loop, the if condition, and basically increment x by 1, and then you use the draw circle again to draw all the points in all the 7 other octants using x and y, and then wind up the while loop. Okay, so this is the version 2 algorithm. Okay, these were the initial steps. I repeat again. Then there was a while loop, then was if loop, and if h is negative, select east, increment h, increment first order differences. Else condition, select southeast, increment h by the southeast first order differences, increment the first order differences, decrement y, come out of the if condition, increment x, draw all the points, keep on doing this as long as you are in the second octant. So this is the algorithm which we have for the case of the drawing a circle in the version. We will quickly go to the example, the same example which we used for the version 1 to draw a circle with center at 0, 0 and radius. What was the radius? 10. Okay, so we did that with the version 1, where we have to calculate at each iteration the first order difference delta E and delta southeast using the xy coordinates. Remember the calculation, some multiplication of x into 2 plus 3 2x minus 2y plus. Now that is not necessary. You now start with an initial condition not only of h but of the first order differences, and within each loop you increment that with second order difference. That will be interesting. So let us look at this table once again and start with the example where the radius is equal to 10 and the initialization consists of 5 steps. First point of course is 0 comma r. So it is 0 comma 10, no doubt about it. H value of course will be the same, which is 1 minus r is minus 10, but in the initialization steps we have 2 values of delta E and delta southeast. 2 values of the first order difference is a part of the initialization step itself, where delta E, what was delta E? It was 2x plus 3, so since x is equal to 0, so you have 3. And what was delta southeast? 2 into x minus y plus 5. So minus 20, 2 into 10 is minus 20 plus 5 minus 15. So I hope the calculations are easy to follow. So those are the starting values for the first order differences, and we now open the table and start to look at the steps of the operation. Okay, and I can go this time faster because you have followed what I was doing in the previous case of the version 1, incrementing all the decision variables, and in this case I have to increment also the decision variables of the first order differences. So you entered the first iteration with the h value minus 9, which forces you to select as usual the east. So you select 1 comma 10, plot that point 1 comma 10, and what you do, you have to keep incrementing h, delta E, delta southeast. What do you do for incrementing h? It is minus 9, h is minus 9 plus 3, because you have chosen east, so delta E will be 3, which will be used to increment h. Minus 9 plus 3 marked in an on black color will give you minus 6. And what do you do to increment delta east and southeast? Since you have chosen east, you increment both by 2. In fact, it will be interesting to note, the delta E will be always incremented by 2. In this third row, delta E will be always incremented by 2, delta southeast may be incremented by 2 or 4, depending upon whether you choose east or southeast. So blindly follow the logic. The first order increments of the first order differences are the following. Increment delta E always by 2, invariant of whether you are choosing east or southeast. The first order increment or the increment of the first order differences for southeast can be incremented by either 2 or 4. If you are choosing east, you choose 2. If you are choosing southeast, choose 4. That is what we derived. Okay. So now if you see the values were 3 and minus 15, increment both by 2 because you have chosen east. So 3 plus 2 is 5, minus 15 plus 2 is minus 13. Look at minus 6, obviously the next choice is 2 comma 10, that is what we have selected, and since you are choosing east, 5 plus 2 is 7, minus 13 plus 2 is minus 11. Very straightforward. Next few iterations are very straightforward. Look at minus 1, you have to choose the next one. What is the next one? 2 comma 10 is chosen, you basically choose 3 comma 10. Okay? You basically choose 3 comma 10. Okay? First value was 0 comma 10, first iteration gave you 1 comma 10 which is this, second 2 comma 10, third 3 comma 10 because from minus 1 is less than 0 and minus 1 plus 7 will give you 6, increment 7 by 2 gives you 9, increment minus 11 gives you minus 9. Okay. Now, for the first time the age value has become positive, so you have to choose southeast, and if you have to choose southeast, the next value after 3 comma 10 will be 4 comma 9. So, choose comma 4 comma 9, mark it, okay, and then what you have to do is increment 9 by 2, the first order differences for east, 9 becomes 11 plus 9 plus 2 is 11 and minus 9 has to be incremented by 4 because you have chosen southeast for the first time. Any times you choose southeast, you have to choose increment by the second order difference is 4 is what you have to use. So, minus 9 plus 4 will give you minus 5 and this is the minus 9 which is delta southeast. Since you have chosen this, this is now the first order difference which you use to increment h. So, h which is 6 plus minus 9 will give you minus 3. I hope you have followed the calculation. Minus 6 plus 5 was minus 7. Okay, minus 1 plus 7 was giving you 6, 6 minus 9 gave you 3. 4 stages of iteration 5, 7, 9 and 11. These are the increments of the first order differences for east. First order difference of southeast minus 13 plus 2 minus 11, minus 11 plus 2 minus 9, minus 9 plus 4 is minus 5. Why 4 here? Because you have chosen in the fourth iteration a southeast pixel 4 comma 9 from 3 comma 10. Look at h again, it is again negative, so choose southeast which is the point 5 comma 9 as marked here. In the fifth iteration as given below at the bottom of the screen 5 comma 9 is marked here and then 11 is incremented to give 13. Since you have chosen basically the east, so you have to increment h by delta east, so it is minus 3 plus 11 which is the non-blue color, minus 3 plus 11 as the color is different which is used you see to increment h. So, minus 3 plus 11 will give you 8. Okay. So, 8 is the current value of h at the fifth stage of iteration, that is what you have, and then what you see is you use 8 to decide the next choice, east and southeast. Since h is positive you will choose southeast. Since 8, I hope you are following these stages. Please try to work this out yourself to get the new values of h and the next coordinates as you get it out, and then otherwise if you miss one particular point you will not be able to follow the steps yourself. Okay, try to predict yourself. So, look at the fifth iteration now where we have chosen 5 comma 9 as your east pixel, but you now look at the value of h which is 8, h is equal to 8 and enter the sixth iteration and choose your pixel. If h is positive we choose southeast, we know that. So, choose the southeast pixel 6 comma 8, mark it there. Okay, so, it is marked 6 comma 8 is marked in a red circle, and then what you do, you increment 13 which is the delta E by 2, so that gives you 15 delta southeast. Since you have chosen southeast you have to increment that by 4. So, minus 3 plus 4 will give you 1 and you use actually delta southeast to increment your h. So, h which is 8 plus delta southeast is minus 3, 8 minus 3 will give you 5. Okay, so, that is what you use to compute the new value of h. Okay, that is, so in the sixth iteration you have chosen the value 6 comma 8. Look at 5, remember x is still less than y, and you basically will choose the southeast pixel because h is positive. So, choose 7 comma 7, increment 15 to 17, that is the first order difference in east, and since you have chosen southeast, this delta southeast also will be incremented from 1 plus 4 is equal to 5, use 5 plus 1, increment h by delta southeast. So, 5 plus 1 will give you 6 and you have chosen 7 by 7, that is x equal to y, there is the last point in the second octant and that is where you have finished the stage of the iterations. Okay, and the curve is here, actually you got the same set of points. You got the same set of points with a different calculation, and this calculation never at each stage of iteration it involved only integer addition or subtraction. One integer addition, 1 or 2 integer additions or subtraction, like the scanline algorithm for drawing a straight line, unlike the previous version where we had to multiply and add 2-3 times under each loop. We did not have to do that. The version 2 will definitely work faster because we are only doing integer manipulation. Delta east is incremented always by 2, delta southeast by 2 or 4, and h is incremented by delta east or delta southeast, which is the first order differences depending upon whether you have chosen east or southeast anyway. So, as you can see here that this is a much better algorithm in terms of implementation, it will be much yielding faster. We will wind up today's class by this comparative table, comparison of the solution with two different methods, and the table on the top actually give you the values at each iteration using the second order differences, and the table below, which we have computed in the middle of the class today earlier, are the values at each iteration which have been computed based on the first order differences alone. And as you can see, you just compared the last two rows of x, y, you got the same set of points, 1, 10, 2, 10, 3, 10, 4, 9, 5, 9, 6, 8 and 7, 7. So, the result is the same. Not only that, it is interesting to note that the value of h, you look at the second row of both these tables, the values are all same. So, whatever method you use, either the second order differences or the first order differences alone, you will actually getting the same values of h and same values of x and y. So, it typically means that your calculations are correct, you get the same result. Your algorithm is wrong, if you do a mistake in calculations, when you are doing using hand or the calculator, you will get two different results and something would be wrong. So, this is the best way to check. Pick up any other radius value, instead of 10 you can probably choose a larger value of 14, 15, lesser values of 7 and 8 to compute all the values of x and y using the first order differences alone, 2x plus 3, 2x minus 2y plus 5, use those formulas to get the new values of h, get the new values of x, y, then use the version 2 algorithm where do you use the second order differences to increment within each stage of iteration. You are using the second order differences to increment the first order differences as well as the h. Do that, find out the values of h, all the values of h at each stage of iteration should match in the two stages of the algorithm, independent of whatever be the value of r. If it is not, then you are making a stage. So, we have solved an example today using two different versions of the midpoint scanline algorithm for drawing a circle, first order differences and second order differences. We got same results, we should be happy, but I expect you to probably keep trying this again and again. So that not only this particular example you should try, but you should try another example with a different value of r, and if you get to both the results same, you should be happy that you have not done a mistake. Okay, so that ends the discussion on midpoint circle algorithm today. In the next class we will actually move to the other curve drawing mechanism of the other drawing, which is the midpoint ellipse, drawing an ellipse. Okay, so we will continue that next class. Thank you very much.